Alright, I just wanted to give a quick overview of my Wi-Fi controlled wheelchair. This is one of the first videos I put out. Oh, it's probably been 4 years ago. Haven't really done much with it since then, but decided to get it back out and do a little bit of a description on it. So, I guess we'll start out. What I've got is a wireless router used for the communication between the computer and the wheelchair. So the commands are sent through over Wi-Fi through the router, and then what's connected to the router is this board right here, which is a Lexol Ether IO 24, and basically what it does is it has 3 ports on it, 8 bits wide, I believe. I can't remember. Yeah, 3 times 8, 24 of them. So they're basically parallel ports that are controlled over Ethernet and actually using UDP to send the data to it. So you send a command like A, I think it's A, and then a number that you want to set the 8-bit value to on these ports. So that's basically what I did to control this way back when I put this together. So to change the direction and speed of the wheels, I'm using these 2 ports. This one is the speed. So from this parallel value gets sent from here. I've got it over into this board that I made up here, and this is the actual value that's coming into the controller right now. So just displayed here just for troubleshooting, just to see it. So it goes through here, it goes through. And I think I also did this to lower the voltage, because this is a 5 volt output, 5 volt logic coming through here. Then I use these LEDs with the resistors, so that dropped it down to 3.3 volts, which is what the microcontroller board here needs. So that was just kind of a quick and dirty way to lower my voltage so it could be at the right logic level. So I fed that into a microcontroller, which looks like it wasn't connected good. Well, there we go. So yeah, and then also on this board, these are the MOSFETs I'm using for the relays that control the forward and reverse on the motors. I'll get to that in a second. So what I've got from here, so I've got the parallel port going into the microcontroller, same values going in. Then I do some logic where not all these bits are controlling the speed, only the 7 of them. The 8th one tells it which wheel it is. So when it's on, it's one wheel. When it's off, it's the other wheel. So that way, through one 8-bit parallel port, I can control both wheels. So that's fed in here, and then through SPI, I'm controlling 2 digital potentiometers. So these 2 potentiometers are for each wheel speed. So basically through SPI, I'm controlling where the wiper value is on each of these digital potentiometers. Then from there, that gives me it's something around a 0 to 10 volt signal out, and then I'm feeding that into one of these here. They're different models, but the same thing. They are motor controllers off of electric scooters, 24 volt DC electric scooters. So they had a throttle to set the speed, and it was a 0 to 10 volt signal. So instead of that, I've got it tied to the digital potentiometers, and that's what tells the speed of the wheels. Then I've got a couple relays underneath here. Let's see if we can see them. Yeah, these right here in these gray boxes. If I can get it to focus. These are how I switch the direction of the motor, and that's what these MOSFETs control. And I'm using the B port on this Lexol board to turn on and off those relays to tell it which direction to go. So when the relay's turned on, it's got separate contacts on it. So that's how I was able to flip the polarity on the motors. So basically, when it's going reverse, it'll turn it on. When it's going forward, it turns it off, and vice versa with the other wheel does the same thing. So that way I can do my turning, spin in place, that kind of thing. So I think that's everything on these boards. And then this last board here is just my power supplies. So it's a DC to DC converter, two DC to DC converters. The big one's for 12 volts, which is powering my my router, and also the camera on here, which the original video didn't have this on here. It was something I added later. So that's also being powered, and it's a network camera with pan, tilt, and zoom. Well, no zoom, just pan and tilt. So yeah, then the other supply is a 3.3 volt supply, and that's for the microcontroller, which required that. So that was, what was that was for? So yeah, that's pretty much it for the wheelchair itself. The bottom part hasn't been modified at all. I just used the original connector that the original controls are hooked to, and that's where I fed my signals into. I think all I did is replace the batteries, and I added a wire to make it easier to charge. Otherwise I got to unplug this every time, so I just added some wires to charge it that way. There's my better view of that relay. So that's the wheelchair itself. So here's my joystick I used to run it, and here's the program. I wrote it in Gambus on Linux, so that's kind of my go-to programming language. Doesn't do it all, but it's like Visual Basic. It's real easy to run. So let me start up the program here. Okay. Oops. I'm trying to do this while looking through the camera. All right. So I think that was a test button. This is just a test program anyway. So here's my left and right values. And so the 1 bit, that's why these values are different, because in binary you've got let me think here. So anyway, those different values are how I tell it which wheel. So that's why there's two different values being sent, and they're sent simultaneously. So when it reads one value, it knows which wheel it's for. So yeah, that's pretty much it. And it's just set up to read the joystick. So all I gotta do is forward and back with it, and it'll do its thing. And it's fast sometimes. That's just I got it set so you can twist this joystick, so I can make it rotate when I twist this. You gotta be careful with it. Let's go forward a little bit. So yeah, I've also got the camera hooked up to it. So there's my legs. So as I spin, I can watch where I'm going. And then also what I've done is I've also made it where I can control the pan and tilt with this little top joystick here. So I push up on it, which actually that's down. I got it reverse controlled so I can aim the camera wherever I want to. Let me get a video of that. There. Got a little delay on it, but serves its purpose. So I think that about explains all of it. Let's see here. That's a simple program, but worked well. I think I'd like to update the controls on it a little bit, make them a little more powerful. Maybe put a small single board computer on it, like the Raspberry Pi. Going to be working on another project that that'll be doing that with. So maybe once I get that one done, I can use the same program and same control setup for this and update it a little bit, clean it up a little bit better. This is kind of a mess. I was just throwing it together, getting it working, but it did work. So that's all I've got for now.